Hello, welcome to this introduction to our RVU University Network Hardware Lab. What I plan to do in this lecture is to introduce you to the network lab that we have set up using Ruckus switches. Okay, this is from Commscope company. We have built this entirely from products used from Ruckus. Now let us look at the lab layout. This is a panoramic view of our lab. If you see this, there is a main rack near the screen, and then we go around in the anti-clockwise direction. Rack 1 is here, rack 2 is here, then rack 3 and rack 4. Now let us look at how the team formations is planned. If you see the location of the network racks, they are in between the two tables. Okay, so when you come in the anti-clockwise direction from the main rack, the first we will see group 1 sitting on this side of the table, and on this side of the table group 2 will be there, and they will be using the rack which is in the middle of these two tables. Now there are many network devices there, not too many, there are 4. You can see them, there are 2 there in the top and 2 at the bottom. What we plan to do is the top 2 is always used by the group which is on the left side of the rack. So you will be, the top 2 devices are for this group and the bottom 2 devices are for this group. I think from this now you will be able to find out for the rack 2, these 2 devices will be used by group 3 and these 2 devices will be used by group 4. Got it? Now let us come here on the right side of the classroom. If you are looking at from the back side, group 5 is here, group 6 is here. These are 2 tables which you cannot see the table here, but this rack is mounted in the middle of these 2 tables. Now since we are going in this anti-clockwise direction, group 5 will be here, okay, and it is shown here. Group 5 is here and group 6 is here, 7 and 8. Now as we said that the top will be used by the group here, because it is on the other side, the top 2 devices are going to be used by group 5 and bottom 2 devices will be used by group 6. Okay, let me remove this and show you exactly what is being used. The top 2 devices for this group and this for the bottom 2 devices will be used by this. Similarly, you can see them, there are 2 devices, 4 devices here, and the top 2 devices will be group 7, this table and this table, you know, in the middle the rack comes, and the bottom 2 devices will be used by group 8. So this has to be very clear. Once you get into the lab, this is the main thing you should understand. So based on your group number, you know where to be seated and which are the devices to be used. Now let us look into the way these devices are configured or connected. Okay, first thing is to worry about how they are connected. Now you can see that the rack 1 and rack 2 only on one side of the lab we are showing you, so that you can get to know about those 2 devices which I talked about. Now you know that these 2 devices are meant for this group and these 2 devices will be used by this group. Okay, now you can understand what is the group number also, because here rack 1 is here, so group 1 would have started first from the main rack. So group 1 will be here, seated here, and group 2 will be on the other side of the table, and group 3 on this side of the table, and group 4 here. Okay, so let me write it down: 1, 2, 3, 4. And then also you know that which are the devices to be used by each group. You should not disturb any other connections or anything with the other devices. Okay, that is meant for only the group which is assigned to it. So you are, if you belong to group 1, you should only be connecting the host on the on your side, or any connection you are making between them, you should do it only with the devices that you are assigned. Now this is clear. Now let us look at what are those devices that we are talking about. Now this is the main rack which is there near the screen, which you can see there, right? This is the main rack which you will not be using it at all. Okay, maybe only the teachers may connect to that and use it. Though you will be using it through connections coming to your racks, you won't be directly connecting to any of those ports here, because you cannot even run a cable which is too long for it. So that's why we have planned it such a way that you use only within the rack, okay, the connections. But there are some connections taking you to those devices, which I will explain you shortly. Now main rack is here. There are normally, you know that there are two things which you know: switch and router. Okay, I will short form for SW is not software, it is switch. Okay, we are in the network world, so it is a switch and a router. There's two different devices. Okay, whatever devices that you see here, all of them, okay, they are all of same model, but you can actually boot them, okay, when you are booting it up on two different modes, okay, like a switch mode or router mode. We will learn about this in little more detail. Right now what you need to understand is, suppose you have a dual boot machine. You know that you can boot the machine as either Windows, or if you have another partition which is having Ubuntu, you can boot it on Ubuntu, right? Once you boot it as Ubuntu, you will be using it as a Ubuntu device, or if Windows is booted up, you will use as a Windows device, right? Similarly, these all the devices that you have in our lab, they all can be booted as a switch, which is a L2 device, or a router, which is a L3, okay, level 3, where the routing can happen. Here only the data link layer, wherein only a LAN connectivity is supported by the switch. There are many VLAN and other things which are there. Right now, assume that these switches are called L3 switches because it can behave like a switch or L2 device or L3 device. So let us just understand this at the basic level. Then later on, let us learn more about it. Now we have a 48 port switch. There are two devices. What is this 48 port? Let me explain that. We have a switch, always switch is shown like this. There are ports which are connected, which are available for you to connect the host. We call it a host, which is a desktop which is connected to the switch. Now port numbers are normally, right now in this device it is numbered like this: port 1, 2, then what is there at the top is 3, and then below it, just below it, is 4. So you can see that odd number ports are at the top and even number ports are at the bottom. Okay, you can, once you see the device very close to you, you will be able to understand that what I mean by that. Each of them are called ports. Okay, now these are called data ports, wherein you connect the different desktops and then they talk to each other, okay, through the switch. So that is how the switches are designed. So suppose if a particular device can accept 48 hosts connected to it, that means you can imagine each of those devices can communicate with each other or communicate they are connected to the network, and they can be on the same LAN or different LAN, and they are connected to the network. So 48 devices can be connected. That's the 48 port means. We call it as a VLAN router. Now you understand that what I mean by router, because it is booted as a router. It behaves like a router, and this device which is down is also a 48 port device, but we are booting it as a switch. It can only perform L2 operations, data link operations, okay, switching and VLAN kind of thing. Okay, now this is in the main rack. Okay, two 48 port switches devices are there. One is configured as a router, one is booted as a router, and another is booted as a switch. Now we also have 12 port devices here. Okay, now all these devices are of model number ICX7150. I encourage you to look at the manual and then try to understand what their features they are supported by these devices. Actually, they are very enterprise grade devices which are used for setting up the lab with a lot of money spent on it. So I want you to be very careful while handling it and make sure that you don't spoil any of them and understand what you are doing while connecting to the device, because this is similar to an IT engineer working on a real network. We have made it for you in an isolated network which is not connected to our university network, but this is similar to how a normal network is designed in any enterprise or a corporate environment. Now, coming back to each of the racks where you will be directly connecting your host and making connection between them or between these different ports, you each of the group numbers are mentioned, and the seating arrangement I told you in the picture, this is how they are going to be. And one thing which you should understand is this is you will be connecting to this one. This will be used by group 5, and this device, two devices are used by group 6. Okay, this is group 6. Okay, this picture is this arrow mark is wrongly highlighted. I will show you in the next picture what it means. Okay, now another thing what you also have in the network lab is wireless devices, which are wireless Wi-Fi routers, which will also be explained to you when we are in the lab. Okay, this is just an introduction, and you know that different racks are there and two devices are there, and these two devices are 12 port devices. That means maximum 12 hosts can be connected to one particular switch. Okay, the main rack devices are 48 port. Now let us come here. Okay, let me explain a little bit more about the 48 port devices. Okay, this is the little better picture of the ports which are all there. Okay, we will understand about them in the next slide. Let me explain. Anyway, you will not be operating directly on this device, so that's why I don't want to spend too much time on explaining the 48 port switches, but still to make you understand, there this all these ports, whatever you see 48 ports are data ports. That's enough. I don't want to spend too much time on this particular device because you will not be directly connecting them. Now let us try to spend some more time on this 12 port switches which you will be connecting directly to. And you can see, if you count it, number of ports here, there are 6 ports, and bottom 6 ports are there. 12 ports are there in this device. That means 12 hosts can be connected. And now you know, based on the numbering that I have given, port numbers, it starts from left. This is port number 1, and what is down is 2. Then this is next one is 3 and 4. So if we say that we are now connecting to a port, we call it as Ethernet. Okay, a short form is ETH, and we will call it as 1/1/1 for this particular port. Okay, I will talk about later on what this 1 means, but at least right now you understand that when you see some picture saying that you connect a host to 1/1/1 means you are supposed to connect it to this port. Okay, now you can imagine what is the bottom port will be called as, it is 2, 1/1/2. So similarly up to 12 you will go. Okay, these are the naming or how do we represent each ports in our network diagram. Now as you are aware, this S1 and S2 are the naming given to it. Let me maybe show you the naming convention later on. Now one more thing, let me explain here. This is the data port which I told you that you connect to the device, but as such this device is fresh from the market, company. You have to configure it, right? You have to, based on what network you are IP addresses or network ID or assigning to a network, all those things, various configurations need to be done. You cannot just directly connect your host and then start using it. So there must be some means of configuring the device. To do that, there are two ways that it can be done. Okay, if you now see the 15, it is called console port. Okay, console port is a serial actually. Okay, serial 90 9800 baud rate. You might have used it in your Raspberry Pi RP2 for 2040, the ESM course, or any of those Arduino board or Raspberry Pi Pido. You know that serial port is there, which is 9800 baud rate is normally used, but you can use higher data baud rate also. But when this device is shipped, it is configured to interact with the any host device. Okay, I'll call it as a host because you are connecting a desktop in a serial communication, using serial communication. Though the port looks like a Ethernet port, it is the physical device, physical interface is like that, but it is actually a serial communication. RS232 is what is being used for communicating with the device. Now, why do we need a console port? Because you want to configure the device by giving some commands which are specific to the device. When I say device, it's a network device. Either it has been booted as a router or a switch, it doesn't matter. But there are some commands which is defined by the manufacturer, in our case Ruckus or Commscope company. So you have to give those commands through a serial interface and then configure it. That is one way of doing it. Now you see that there is 14 and 13. Okay, they are 14 is a USB port, 13 is management port. Okay, now there is one more way of configuring the device using the management port. Now let me give a scenario wherein now suppose you might have gone into a mall. There are some lifts meant for the people who are coming to a mall for shopping, right? These are all for customers. But there are some lifts which are at the normally at the back where the staircase is there. It's called service lift. You might have seen that service lift, which is rugged and bigger than what you see for the customers. And normally they ship a lot of items, and what is meant for people who are managing the mall. It is same in any big theaters or any big places where you see there is a separate lift meant for service people to take their items and go and do some management of different things or taking care of maintaining the infrastructure there. Similar to that, there is a management port which is meant for managing the device. So this is actually Ethernet. Okay, this is also Ethernet. But what you connect, if you connect a device here, a host device, it is not meant for sending traffic over the network. It is only to configure the device. It is used by IT admin. Okay, it is this whatever machine you connect, it is used by IT admin to configure the device. Whereas the host connected to these data ports, which is 12 port or 48 port, what I told, these are all meant for the hosts which are there in the network to send traffic, to communicate with each other. They are not meant for managing the devices. It is similar to what you see in a normal ring road, right? There are service road on the sides, which is normally not bad condition than compared to the main road. Here the normal traffic goes, right? Normal traffic, cars and vehicles go, but this service road is meant for managing this, toll gate or the particular highway for any break, no accident or anything happen, any vehicle is broke down, then they come and rescue. So the service road is meant for servicing the highway. Similar to that, this data ports are meant for normal traffic. Management port and console port are for managing the device. So there are two ways of managing it. So one difference between the console port and the management port is you can connect a device here. You should be near to the device and you should connect to a serial console cable. It is called console cable, and then you can configure only this device. So it is not on the network. Okay, you can only configure on this particular device using the console port. You cannot do it by logging into this and manage some other device. Now, let me tell you, suppose you have different network devices. Okay, they are all connected through some LAN. Okay, let me call it as some, it is the management LAN or whatever. Then what happens is, if you connect a host, you can either configure this device, because each of this management port there will be a separate IP given. So IP1 is given, IP address 2 is given. They are all on the same LAN. Suppose all the devices are connected through the management LAN, then you can actually, you connecting to the management port, you can log into any device and configure them. So you don't have to be physically, whatever device you are connecting to, it is not that only that device you can configure. You can telnet, or telnet means you are logging into the device and running it as if you are connected to the device directly. Okay, so just to summarize, console port is to only connect to a device and configure that particular device. Okay, this is console port. Whereas management port is, each of those management port will have some IP address. This is, suppose if you have a management LAN, okay, you call it as management LAN, and then many network devices are connected. This switch 1 is connected, switch 2 is connected. Okay, all different devices are connected to this management LAN. Then you can telnet. If suppose your host is also connected to the management LAN, you can telnet, okay, telnet to any device on the management LAN and configure it. So that flexibility is there. So you don't have to be physically there. You can sit in one rack and configure somebody else's, but which I don't want you to do it. But what I'm saying is, you are capable of doing it. That's the difference between a management port and a console port. Okay. Maybe you will understand it once you start using it. Now there are other kinds of, you might have seen in your home, the broadband connection is optical cable is there, which is very high data rate, whereas Ethernet cable is also right now catching up, but optical cable is much ahead of Ethernet speed. So there are SFP, which is called small form factor pluggable, which is for optical cable. We won't be using that in our experiment. So the 8, so you can see 7 and 8 are there. You can see this are all. This is the last one. What is given is SFP port, which is meant for connecting the optical cables, which we will not be using. We are using only Ethernet cable in our lab. Okay, now let me quickly go. I think this introduction is enough for you to have a good idea of what I'm explaining it. So there are Wi-Fi devices also in our lab, which we'll be using it later on. These are the different specification of this wireless LAN. I'm not going into the details of them. Now let me tell you the grouping of how we have organized the lab. Each of the groups G1, G2 are coming here. Okay, rack 1, this R1 is here. All the devices given here are starting with the R1, and the top one, I said that it is meant for group 1, top 2 devices, and bottom 2 devices are for group 2. So they are named as, the devices are called S1 and S2, but you can actually, S is meant for actually switch, but actually you can make this device to boot as a switch or a router. Okay, so both modes are possible. We will explain you in each experiment whether you are using it as a switch or a router. Right now we are naming it as a S1, S2. So if you belong to group 1, you can, now you know that you can use only these two devices, and you will also know that there will be a management port for this. IP will be there, management port, and this also will, some IP address will be given. Only you can telnet to these management IP ports and configure those devices, because you are required to configure only the device which is assigned to you. Do not log into somebody else's switches and tamper with it. It will be considered very offense, serious offense. Okay. So now R1, group 1, group 2 is going to use it. They will be sitting on both sides of the rack. G1 will be onto the rack's left side, and on the right side is group 2. Similarly, rack 2, group 3 and group 4 will be using here. Here you see that the group 5 will be using the top two devices and group 6 will be using the bottom two devices. Here 7 and 4. Okay, always remember odd number is at the top. The group number is odd, then you are supposed to use the top two devices. If your group number is even, you are supposed to use the bottom two devices. And anyway, naming is there, and you know where the seatings arrangements are. So it is very easy to understand what you are supposed to do. Now, let us understand them little more in detail. I am just giving you a closer view of only rack 1 for an example. So similarly, if your group is not G1 or G2, okay, G2 will be using this, group 2, group 1 will be using this. Similarly, like rack 2 or rack 3, rack 4, you know which one you will be using. So these are the naming which I told you. And as you can understand, they are 12 port devices. And you can see that these are the management port, okay, management port. Now, why are they connected? Let me explain this little bit. I told you that management LAN is there, right? And different devices are connected to that. Now, how do you connect it? How this S1, whatever S1, S2 of each group is all connected to a particular LAN, which is management LAN. Now, how can you do that? Only if you have a switch, management switch. So we are using the 48 port management switch, which is there in the main rack. Okay, I showed you the picture, which is down 48 port switches. They are all connected through this patch panel. Okay, patch panel is something, the whatever is there in the top is called patch panel. Okay, it's called patch panel. Now they are helping you to make connection from here to the whatever is there in the main rack. Okay, so it is like a connection going from your rack to main rack. So let me show, I have not explained that part of it. So you can see that some wires are coming. It's not a single wire is coming, many wires are coming. In the lab, you can see that there are a lot of blue wires running from the main rack to this individual racks. So whatever is the patch panel, PP, is shown on top of each of your rack, they're all connections taking you to the main rack. Now in the main rack, there is a management switch and there is a VLAN router. Let us not worry about it right now. This let us little bit understand more. So when you have a connection of all these devices management port, which I showed you in the next diagram, this particular management port, if they are all connected, okay, through this connection, okay, all this management, the devices are connected to the management switch. So let me explain. This is as a, let me call it as a management switch. There are different ports. Now these devices are, each of the devices are like a host, okay, as far as this management port 48 port switch is concerned. So their management port is connected to this. That means if I give an IP address, some 192.168.100.10, and then this is 11, similarly, okay, this is the IP address and this is the host address. Then each of those devices are like a host as far as this 48 port management switch is concerned. That means what? If I have a host, a desktop, okay, connected to the same switch through some other port, and I give you some number 198.100 dot maybe 15 or 16, then what happens is this device is also like a another device on the same network. So they can actually, this host can telnet to this particular device, or it can telnet to any other device which is on the same LAN, and you can configure it. So when I say telnet, you are actually logging into the device and running some commands on the device. Okay, so that is how you use this management switch to make your host connected to the management LAN, and you can telnet to a particular device. Now, what do you need to know? Suppose if I want to configure my device S1 or S2, I should know what is the IP address of it. Then I will say telnet, okay, telnet, okay, and then the IP address. Then I will go into that device and then configure it. Okay, just understand this is how we are going to be using this lab. So even if you don't understand it fully, once you start using it, you will be able to connect what I am saying. Okay, so this is how the setup is you have an ability by connecting your one of the hosts. We are going to give you three hosts. Okay, host when I say is all desktops. Okay, very Windows desktops. I am going to we will be seeing three hosts on the table. Two are meant for data traffic. Okay, two hosts are I'll say H1, H2. Okay, meant for data traffic, and one is for management. Okay, this host will be for management. That means what? You will be connecting this host to this management switch through this patch panel. Okay, we'll explain you how it is done once you go to the rack and then explain you. You will be able to make sense out of it. Then what happens is your your host each group will be given one host, one desktop, which is meant for connecting to the management switch. Now, once you have it, you will be able to telnet to any of your switches or even the VLAN router, okay, which is in the top. You are only supposed to configure only these devices which are meant for you, because though you have an ability to log into any switch that you have in the network. So similarly, every device is on the same management LAN, and then every group is also given one uh, desktop which is connected to the management LAN. So that is meant for configuring them. Then other two hosts are given for connecting to the data port and then sending traffic and ping from one to the other, so that you see that whether traffic is going through or not. So we are only going to ping command. We are going to use it to establish or verify the connectivity that you have made. Okay, I hope this has made it somewhat clear. Okay, now let us, this is the naming of these devices. Now patch panel, uh, let me explain a little bit more. This is the main rack. Okay, you are not going to be operating this only, maybe this picture only you will be seeing it. Now I told you that there are two devices, right? This is a management switch which is down, and top is a VLAN router. We will not worry about it right now. We are going to have a management LAN like this. Okay, I hope you understand what is /24 means. That means 24 bits starting from the higher or bit, 24 bits. You know that each of those things are 8 bit each, right? So 3 into 8, 24. These 24 bits represent the network portion of the LAN. So 192 or 168 or 100. So if suppose you are connecting another host to you to this LAN, it should also have the same number, right? And the host should be different. No, any host connected to the LAN should have different IP addresses. Now I told you that even the devices, all S1, S2 that is there on each of the racks are on the same LAN, they will also have the IP addresses. So you have to give some IP address which is meant for your desktop, which you will be given one device for, one host for each of the team. So group, so you will be assigning one IP address to that, which is, no, I will tell you the range of addresses that you can use, so that you are now on the management LAN and you can log into any device, telnet to any device and configure them. Okay, what commands to give, we will worry about it later. Right now, just know that you are having the ability to log into any device, telnet to any device and configure them. Now, there is another router which is also accessible to you through your patch panel on the top of the rack. Okay, we will not worry about it right now. You are given 6 ports for each group, which are terminated on the let me show you, they are terminated on your patch panel here. Okay, there are, sorry, what I am showing you is these 6 ports are uh, actually coming from the main rack. Okay, maybe I will give you when I come to that part of it. I will we will not be using it immediately in the first experiment, but soon you will be using it. Okay, now naming conventions are, this is G1, G2 is group 2. Okay, now I am talking about rack 1 only. So let us see that on rack 1, since you can see the main rack is here, then rack 1 is here. Okay, main rack 1, group 1 is here, group 2 is here. So this portion, the top portion is meant for group 1, G1. Okay, So it is top one, top left is group 1 and top right is group 2. Similarly for other 3, 4, 5, 6, 7, 8 and all that. Okay. So only when you go to the other side of the rack, the right side of our machine, suppose if you have rack 3 which is further away from the main rack on the right side, group 5 will be here and group 6 will be here. Okay. So this side. So these are all the ports which are coming from the VLAN router. That means if you are connecting here, it is equivalent to connecting to the VLAN router switch there. Okay. So you have, see, a group 1, C1 to C2 to C6, 6 ports are connected to you. Okay. These 6 are actually meant for connecting to the VLAN router. We will worry about it later. Right now, it is a little more difficult to understand what I mean by this. Maybe let me, just for the completeness sake, let me tell you, this is the VLAN router, 48 port switch which is there, router which is on the main rack. There are 6 ports. Okay, 6 ports taken from here given to group 1. Okay, that means if you are connecting to this, suppose you want to connect your host to this port on the VLAN router which is in the main rack, what you will be doing is group 1 C1 you will be connecting, because this is directly, there is a, this patch panel is directly connecting to this. Now let me talk about group 2. Group 2 wants to connect to 7 to 12 is given to it. Okay, as I told you, 7, 8, the odd numbers are on the top and the even numbers are at the bottom. Next 6 ports are given to group 2. Now, if you want to connect your host, your desktop to port number 7 of the VLAN router, then you will be connecting to this group 2 C1. Okay, this is C1, C2, C3, C4. So what we have done is we have taken 6 ports of the management, VLAN router, and then terminated on this patch panel. So if you connect it here, it is equivalent to connecting to the particular port on the VLAN, VLAN router switch on the main track. Okay, this is meant for you to, all the groups to talk to each other. Okay, if you don't understand this right now, in the lab we'll be explaining you when we do some experiments using this. Okay, so now what are we doing it here? This is all meant for patch panel connectivity. Okay, as I told you that 6 ports of the VLAN router is terminated on this C1 to C6, and then I told you that you have 2 devices, right? S1 and S2. They need to be connected to the management LAN. So this actually we are connecting it to this M1 and M2 port, because you know that your switches are physically here on a rack. Okay, rack 1. So the management port is there. So you will connect it to M1, which will take you to the 48 port management switch, so that they will all be on the same LAN. Okay, that's the reason it is first taken to this M1 patch panel, and then where that is connected to the 48 port management switch. Remember, these 2 patch panel connections are connected to the management switch. All of them, these 6 are connected to the VLAN router. Okay, this is how the patch panel connectivity works. Now let us go further. Now IP allocation, as I told you that 192.168.100 is the network, and this is the subnet mask. This, if you apply, this is the network ID. Okay, and this is the host ID portion. Okay, I hope this is clear to you. This is /24 format. Now what we have done, all the devices in the network are on the management LAN. So 100.1 is normally we are giving it to a default gateway, as you are aware, which we have done it in Cisco Packet Tracer. So the same thing is being used. Right now we don't have any gateway connecting to the internet, so we are isolated network. And then we have allotted .2 is for the router, VLAN router itself. That device's management port is this now ID, this IP. And our management LAN switch itself is having a IP address which is 3 and 4 is reserved. Okay. And then this is in the main rack devices. Okay. Now teacher can connect to the management LAN switch directly on the main rack, and they can use 5 to 9 as a host IDs meant for them. Okay, you are not supposed to use any of these reserved IP addresses. I will tell you what are the IP address. You can use it. This is all meant for teachers to be on the main management LAN, and they can log into any of your devices and check the configuration that you have done. So remotely you can monitor what is happening, whether you are doing right or anything is going wrong, so that we will be able to help you out. Now let us come to group 1. Group 1 is given 10 to 14 as the IP addresses which are allotted to the group 1 host. So the devices that S1 and S2 what you have are going to be assigned this IP address which we have already done it. Okay, you don't need to do it. And then you need to connect your one of the hosts to the management LAN which I mentioned. You need to use this IP address only. If you belong to group 1 and you are connecting one host to that M1 port, no, U port. Okay, there is a U port which is meant for that. Where you will be connecting your um, host which is connected to the management LAN. You have to use the range of normally you are going to use only one IP address, so use 15 for group 1 and group 2 will be using 25. So we have put 2 to mean that it is meant for group 2. Okay, and 1 starting from 10 to 19 is for group 1. So I think you will be able to understand the allocation of the IP addresses. That means 30 to 39 is meant for group 3, 40 to 49. Okay. Similarly, first 5 is for the host IDs of network devices, and the next 5 is for host IDs of the host machines that you are connecting. When I say host machine, that is the one which is connected to the data port, and no, so that is connected to the management LAN of the devices. Okay, when you want to telnet to the device and configure it. Okay, so and then wireless IP routers, AP access points and controller are assigned some other IP addresses, which is 201 and 202. And then when you log in, normally this is the default factory set. We don't have to worry about it. You have to log in as super or RVU. Either you are going through a console port or through management telnet it to the management LAN. You have to use super and RVU or small letter to log into the device and then start configuring the device. Okay. I hope this is video gives you a good overview of how different devices are connected, how they are configured, what are the IP addresses assigned to them. Some of the IP addresses assigned to the devices are already done by us. When you connecting your host, you have to give an IP address on the same management LAN based on which group you belong to and what is the range is given to you. Okay, 15, 25, which I mentioned is what you are supposed to use it. Okay, see you in the lab. Bye bye. Now, first experiment we will see later. Okay, in the next lecture. Bye bye.